Very good afternoon, students. This is regarding digital communication system and too about encoding techniques for MRI signals. So mainly the MRI is a term which is derived from the word binary. So the binary symbols can take two levels, zeros and ones. So if it is a combination of a given number of binary variables, if you have more than two numbers of levels, we call that signals as MRA. It simply represents the digits that corresponds to the number of conditions or levels. For example, we can consider a digital signal with four possible conditions. A digital signal with the four possible conditions, that is voltage levels. It can be of voltage levels, frequencies, or phase, and so on. The MRA is a system with the m equal to 4 levels, number of levels equal to 4. If there are 8 possible conditions, then m equal to 8, and hence and so forth. So the number of bits necessary to produce a given number of conditions is represented as n equal to log to the base 2 of m. So now how many number of levels is needed? We should determine that. We should decide that first, and we should decide that first, and based on that the conditions, based on the number of levels, we can decide the number of bits needed to transmit the particular signal. For example, we can have a BPSK, that is binary phase shift keying technique. The PSK, we know that the PSK is the phase shift keying technique which is used to transfer the modulate, demodulate, the transfer the signals of binary in nature. We have two regions, that is zeros and one region, the message point 1 and message point 2, that is above 0 level and below 0 level. We call that as the region 1 and the region 2. We have the decision boundary for particular level of signals, how we can denote it as number level 1 and how we can denote it as level 0. So this is the binary BPSK signal overview. That is, we have the signal of two levels, that is root of EB, and we have signal levels, root of EB by TB, that is the amplitude of signal, and can be of plus and minus values. We can represent it in both the ways, sine wave and cosine waves. That MRA PSK multi-level modulation technique permit the high data rates. We have the important equations regarding that. A convenient signal of set of signals for MRA PSK can be represented as pi of t equal to a into cos of omega c into t plus theta I, where this is the carrier signal with along with the phase shift theta I, we take the theta I signals, and where the capital M represents the number of phase signals, then we can take theta I equal to 0, 2 pi by m, 2 into m minus 1 number of times into pi by n. For example, if we have equally probable, that is zeros and number of zeros and number of ones, and that power spectral density of the signal can be represented by the equation of s pi of omega equal to a square, that is the amplitude, into ts into sa square into omega minus omega c by ts by 2. This is the ts is the symbol information rate, or it is represented as ts is the duration of the signal and tb is the information orbit rate. So the relationship between ts and tb is ts and tb is represented as ts equal to tb into log to the base 2 of m. The potential bandwidth efficiency of MRA PSK can be shown to be the bandwidth is equal to fb by b log to the base 2 of m bits per second by hertz. So we have the constellation diagram of MRA PSK. the constellation diagram, that is for 8 PSK and 16 PSK, we have the differences. So the given incoming signal has to be converted into phase shifted version of 8 levels or the phase shifted version of 16 levels. How it can be done? It is shown in the. It should not overlap with each other. Each should be differentiated. Each should be separated by a phase shifter. So it can be done by the 8 PSK modulator. We have the in-phase QIC. This is the block diagram of, for example, 8 PSK modulator. The 8 PSK modulator, it is having a QIC terminal. That is, Q is the quadrature component and I is the I channel is the in-phase component, and C is the component which is being which is the recreation of this. So Q signal, it is coming to the 2 to 4 level converter. It is merely the input data bits are coming to the Q level. It is directly be given to 2 to 4 level converter, and in I channel it is again it is having an amplitude of FDB by 3, and it is again given to 2 to 4 level converter. The 2 to 4 level converter, it is being inverted and given to the Q channel quadrature component. In phase component will not have any phase shift. The quadrature component will have a phase shift of 90 degree. So the signal will have a sine component and cosine component. Merely the 2 to 4 level converter is a digital to analog converter. So DAC will do that operation. And we have the PAM circuit, that is product modulator and pulse amplitude modulation. So pulse amplitude modulation is amplitude of the pulse is being varied according to the incoming bits. So we have the product modulator for doing this sine component and cosine component. Also the reference oscillator will produce a sine component to the first product modulator, and the reference modulator will do the phase shift of 90 degree and is given to the lower level product modulator. And this is again given to the band pass filter circuits, and we have a summer circuit, linear summer, to do the operation of consolidated operation of this, and we have the band pass filter to convert the 8 PSK level outputs. So the main concept is the incoming data bits has to be converted into 8 PSK levels, 8 different PSK levels, and that is being done by the QIC terminal. Q will have a direct digital to analog conversion. I will have a phase shifted version of that, and I will have the in phase component. Q will have the inverted version of that, and the output of this is being given to the pulse amplitude modulator or product modulator circuit. There the sine component and cosine component is we have 4 different combinations. Here in the voltage levels also we have 4 levels. For example, the voltage of I and Q bit determines the polarity of the output voltage. Either can be plus V volt or minus V volt. If it is logic 1, it will be determined by plus V. If it is logic 0, it is determined by minus V. And for the C bit is determines the magnitude of the incoming signal. The magnitude is we have 1.307 volt and logic 0 is 0.541 volt. So logic 1 is 1.307 and logic 0 is 0.541. So we have a 4 level converter. So we have the combination of plus or minus 1.307 and plus or minus 0.541. So we have 2 plus 2, 4 levels. And the remaining 4 levels are being done by using the sine component and cosine component. This is a phasor diagram which represents all. So it is sine component and cosine component. So sine will have a plus term, cos will have the plus term, and either sine or cosine will have the plus and minus term. So based on that we have 4 combinations. And similarly for the voltage levels, 1.307 will have plus or minus, 0.541 will have a plus or minus. So in this way 4 different phasor values are being generated. In this way the 4 different values of phasor values are being generated, and that is the constellation diagram for this. In this way the phases varies the time relationship. So we have the 8 PSK receiver. The reverse operation is being done by this 8 PSK receiver. There we are ended with the band pass filter. So here we start with the band pass filter, then we have the product modulator and carrier recovery signal and product detector. There we do digital to analog converter. Here we will do analog to digital converter. And the output we have the QIC module. So the Q component is the quadrature component, I component is in phase component, and C will decide the voltage levels. So we are recovering the PSK, that is the output data bits. 8 PSK input is given for the receiver, and we receive the output 8 data bits. So based on this study, we have studied something about that is MRA PSK. So we have started with the BPSK, binary PSK. Only we have 2 levels. If we want to levels change, according to that we need to generate the number of phase shift values. That is being done by the modulator, and working of PSK modulator is being determined, and that is being explained by the constellation diagram. And then we have the receiver circuit, which is the reverse of this. Thank you.